Good morning, Sixes. I hope you're all doing very well. Today we'll be learning about energy. We will be looking at how we can define energy, what it means to use energy, where energy comes from, and how different forms of energy can be seen in our daily lives. You may already have some sense of what energy means because we use it very often. We can say, "Oh, I have so much energy because I ate a lot today." Or, "Wow, that kid seems very energetic because he's running everywhere." But what does energy really mean in the context of science? In science, the way we can define energy is the ability for an object to do work. And an object can be any objects that are around us, such as pencils, cars, airplanes, bicycles, or even ourselves, such as our body parts like arms, legs, and etc. You may also be wondering what work is. According to Wikipedia, work represents energy transferred by force. You may need work in order to lift up heavy things. You may need it to push things, climb the chairs, or walk around. So these terminologies kind of use each other in order to define each other. Where is energy supplied from and how can energy be stored? You might wonder. If you think about it, there are many things around us that cannot function unless energy is supplied or stored. For example, you may not be able to function and use energy without eating any food or drinking water. Energy sources represent where energy comes from, and the biggest source of energy is our sun. Other sources can be divided into primary sources of energy or secondary sources of energy. Primary sources can be used directly as they appear in our natural environment, such as coal, oil, natural gas, and wood, nuclear fuels, the wind, tides, mountain lakes, and the rivers from which hydroelectric energy can be obtained, and the earth heat that supplies geothermal energy. Those are all examples of primary sources of energy. Secondary sources of energy is more convenient forms of energy which are changed from other primary energy sources through energy conversion processes. Energy conversion is something that we will be talking about later on this week. Some of the examples of secondary sources of energy may be food or electricity. When we cannot reuse a source of energy after using it once, we call them conventional sources of energy or non renewable energy resources. These conventional sources of energy can be used as fuel for a very long time. Some of the examples include coal, oil, or gas. And on the other hand, non conventional sources, which are also called renewable energy resources, are resources that come from Earth's natural environment that can be used over and over again. So, some of the examples might include the sun, wind, agricultural waste, forestry waste, and biofuel. If there's a supply of energy and energy sources, there must also be energy storage. Energy storage is the capture of energy produced at one time for use at a later time. There must be energy storage for the energy to be released. Let's take a look at some of the examples. If you look at the image, stretching or squishing a string also requires energy. In this case, there is a store of elastic energy. A hammer also requires energy for it to be lifted. When you lift a hammer up, it stores energy because you're overcoming the force of gravity, pulling it downwards. So we say that a raised object is a store of gravitational potential energy. Another example is when water is stored behind a dam. This is also an example of gravitational potential energy. As the water flows downward, its energy can be used to turn a mill wheel or to generate electricity. Many other objects, such as clocks or flashlights, also only function with energy storage. For these objects, batteries store energy to make them work. If we were to apply the concepts learned to ourselves, another question we may ask then is, how do humans store energy? Mostly, humans store energy by consuming food and other nutrients. We have different types of nutrients we eat in order to store energy in our body. We are able to release energy by doing work, and an example would be respiration. As we learned from our past unit in microbiology, all living things have the characteristics of respiration, which means that there are chemical reactions in cells that break down nutrient molecules to release energy. So, this whole process of respiration is also called chemical stores of energy because there must be a chemical reaction to get the energy out of your food. Other interesting examples of chemical stores of energy might be a battery. Inside a battery, there are chemical substances that react together to produce electricity. The chemicals inside a battery can be quite hazardous. Next class, we'll be learning more about different types of energy, including thermal energy and kinetic energy. I hope you learned something new today, and bye for now.